Tom's got his panties pulled down.
So today on the bench we have a Motorola. It's a model CM550. So it's basically the same as the base station. It's just a mobile radio. And if you've ever seen the inside of the base stations, you'll realize, yeah, it's definitely the same radio, because they literally, if you take the faceplate off of this radio and, you know, all the controls and everything, but leave all of this chassis, the steel chassis, that's exactly what's inside the base station, to include the mounting holes for the mobile mounting bracket. So, yeah, they use the exact same board and bracketry and everything. They just stuffed it inside of a plastic box and called it a base station. They're really nice radios when they work. It can be a bit of a pain in the neck to work on, which I ran into on this one. So, customer got this. He said it did receive just fine. But when it transmitted, and you didn't have to be transmitting the whole time. You could just turn the radio on, walk away from it, come back in like 15 minutes or a half hour or whatever it was, and you'd pick up the microphone, you'd key it, and nothing would happen. It wouldn't transmit. You'd turn the radio off for a while, come back, turn it on, it would transmit just fine. You'd let it on for a period of time, and then it would stop transmitting again. So the first thing I checked was at the PLL to see if the lock detector, if the PLL was going out of lock, and it was not. But for some strange reason, the PLL unlock transistor, which is what the PLL actually controls, it was showing a fluctuating voltage. The longer the radio was on, the higher the voltage got. And eventually, you'd actually start to see, if you were looking at a watt meter or a spectrum analyzer and you'd key the microphone, you'd see the power slowly start to decrease and decrease and decrease until, yeah, it just wouldn't transmit anymore. And that's because the transistor wasn't really switching on and off. It was kind of in its in-between state. You know, if it wasn't being used for a switch, transistors actually amplify, and they have a fairly linear amplification. Well, when you use a transistor as a switch, you either want it completely off, or you want it hard on, so it's completely on. And it was hovering in that in-between state. Well, you don't want a transistor to hover in that in-between state when it's being used as a switch. And it didn't appear to be that there was anything wrong with the PLL, because as far as the PLL was concerned, the PLL was in lock. You check the voltage of the logic level at the lock detector, and it was just fine. But yeah, that transistor had me thrown for a loop with its varying voltage on the collector. And, of course, these are a pain in the hoo-ha to work on because of, well, actually, it's that thing that's blinding the camera at the moment. This can. So, yes, this definitely just turn it off and get the microphone unplugged here. Get everything unhooked from it so I can flip it over. Yes, these are a pain in the neck to work on because they have all of this shielding. And yeah, there's screws holding it down, but yeah, then they have straps coming across. This shield here is soldered to tabs all around, all over the place. You have to take that shield off, then to desolder this can to get it off, and you have to pull the entire faceplate of the radio off to be able to get the can out, because it runs into all of the switches and the display board right here. Yeah, they're just a pain in the neck. And then even once you get this off, you still can't work on anything inside that can. It's potted in wax. So what I do is, actually the thing that's holding my camera right now, I actually suspend the radio standing, kind of hanging upright, and then take a heat gun and had to melt all of that wax out. That's why you can see there's even some wax residue down in here. I had paper towel shoved in here and laying on the bench as all the wax oozed out of the radio when I melted it out. But once I got in here and actually, doing some diagnostics, I could actually see the parts because they're not covered in wax anymore. I was like, well, it looks like a bad transistor. That's kind of a sign of a bad transistor. It's just kind of varying, doing its own thing when the base and the emitter are constant, but the voltage on the collector, like I say, it was just varying all over the place. So I replaced it, turned it on, and I knew I should have 0 volts there, and I didn't. Even with a new transistor installed, I still had something like 2 point something volts turning the radio on cold, and as I left it on for a while, eventually that voltage got up, and eventually the power would start to decrease, and eventually it would stop transmitting again. And it's, what in the hell is going on with this thing? It finally dawned on me what someone had done to this. So it has channel modifications. For starters, yes, they butchered the radio. They got holes out the side cover of the thing. So yeah, there's 2 switches on the side. This front switch is a 5K switch. And actually, this switch here is also a channel switch. You can see there's wire goes down to into the PLL area, the synthesizer section, and then a little blue wire here goes down. So yeah, that's another part of the channel modification, is that switch. But what was actually causing the problem was this switch right here. I don't know how to put this, nitwit, when they did their channel modification, they had this switch wired partially. Well, not partially. They actually had one terminal of this switch wired directly to the lock detector on the PLL. They had actually cut the trace to the lock detector, put one wire on one side, one wire on the other side to the switch, and then another wire over to a different pin. And then actually another wire came up, and it was attached to a diode in here. And when I saw all that, I was like, I'm not even going to bother trying to trace this out. It's just got to go. You can't just go tapping into the lock detector. So yeah, once I removed all of that hocus pocus someone had done with this channel modification, turned it on, let it sit for about 15 minutes. Actually, I didn't even need to let it sit that long, because once I turned it on, I saw I didn't have that voltage present, but left it on for about 15, 20 minutes or so, and it was still just fine. So that fixed that up. While I was inside the can, I went ahead and replaced the tantalum capacitors in there, because like I said, it's just a royal pain in the neck ever getting into this. I did replace all of the electrolytic capacitors in the radio, and like I say, while I was inside, I didn't replace the other tantalums out here, but the ones inside this shielding can right here have been replaced to prevent, hopefully, anybody from ever having to get back inside of this thing again. Otherwise, let's see, what else? I had to replace a couple cracked cores. Some of the ferrite cores were cracked in the transformer, the tunable transformers and coils. So I removed both of those, got them extracted. Luckily, they're open on the bottom side, and was able to extract them out and pop new cores in there. Other than that, it was good working radio. Now, apparently, this thing was really horrible looking when the customer got this. I don't know. I didn't see it when the customer got it. I guess he's cleaned it up some. He painted the covers because he said, it was, I guess, pretty deplorable looking condition. So the cover right now doesn't even have a speaker in it. So I'm assuming he hasn't even put the speaker back into it yet. Because here's the wires for it, and he did not mention that he wanted a speaker installed in it. But otherwise, so it's back up and running and working properly now. And you just heard I had it hooked up on air. It's a good sounding radio. It's one thing these radios are known for, very good sideband radios. So, this thing's ready to go again. Replacing the electrolytic capacitors in these, I will give a word of caution. I wouldn't go as far as to say these boards are easily damaged. They're actually, it's not like they're low quality boards. It's a Motorola. So, this is basically built, you can just see the structure, how well they designed this thing. It's built basically to the same standards of the business band radios of the day. And it wouldn't surprise me, actually, if even some of these, like this horseshoe bracket right here that wraps around the radio, that might even be a carryover from one of their business band radios, for all I know. Motorola was known for doing that kind of thing. But some of the circuit traces, when you're removing the electrolytic capacitors on these, be careful. It's very easy to wipe the trace off of the board. Now, usually the only ones you'll have a problem with, so these are double-sided boards. You can see there's copper traces up here. Now, you can't even see the copper traces on the bottom, of course, because of all the RF shielding. But if you have, let's say, example, this capacitor right here, and it's attached to a circuit trace on the top side of the board, but it's not attached to any circuit trace on the bottom side of the board, there will still be a circuit trace pad there, a little circular trace, and they are through-plated holes. But because that little pad is very small, it doesn't really have any large trace coming off of it. When you go to desolder your capacitor to take it out, you'll find that if you have your tip temperature turned up too high, or if you just let your tip on there too long, you're going to wipe that little circle right off the bottom of the board. And it just makes it a little bit more tricky resoldering the part back in, because you have to get the solder down in the hole. There's no there's no trace then left on the outside edge of the board. So just be careful when you're doing that. Other than that, all I can tell you is good luck. There are 2 electrolytic capacitors you can't even hardly see it. There's a circuit board down in here. Yeah, there is. There's actually several of them. There's one here, there's one here, there's one here. But this circuit board right here houses, you can't even see that. I was going to say, this shield goes the whole way to the front. But the mode selector switch in these things is I'll be kind, it's a freak. You would think a 3-position switch like this would be like your normal mode selector switch in most radios. It would probably be a wafer switch. So, round switch, couple sets of contacts, round, and you turn the knob, and the contacts move in around the wafers. No. This is a switch almost similar to something like this, so it has sliding contacts. This switch is actually about that long. It takes up a couple inches in the front of the radio. It has a metal gear on the back of the actual shaft here goes through, and then there's a metal gear on the end of it. Then there's a plastic shaft that runs in this direction that has gear teeth cut into it, and then the contacts for that switch are in the back part of it. So when you're turning this switch, you're rotating the gear and actually sliding that shaft back and forth. So it takes up a lot of room in here. The biggest problem is there's 2 electrolytic capacitors on that board, and they are a pain, a royal pain to get out. You're going to have to take the faceplate off, so 2 screws on each side, take all the knobs off, pull the faceplate off. You're going to have to take the other screws out to take the whole faceplate structure loose. Then you're going to have to take the nut loose off of that switch. Even then, you still can't get the board out the whole way without removing all the wires from it, because you'll have them all stretched to banjo string tight. But you can get it back in far enough that you can just get there, and then again, wiring's stretched tight as a banjo string. You can only rotate this front structure around so far, but you can get it just enough that you can get in there with your desoldering iron and get those 2 capacitors desoldered. Your trick then is getting down in there with some really long needle nose pliers, and actually getting the old caps out is easy. You can just shake the radio after you desolder them and they'll fall out. But trying to get the new ones in, because you can't see the holes. Actually, the one you can, but the other one is hidden behind that switch. So, here's the switch body, and there's a capacitor that stands up underneath of it like that. And you can only get it turned about this far, so it's kind of one of those touchy-feely things. What I do is I just take the long leads off the electrolytic capacitor, kind of bend them like a banana, as a partial arc, kind of turn it around there, and you just kind of got to feel with the leads, and okay, there's a hole, and then wait for it to pop in the other one and get it tucked in, and then pull it through with a pair of pliers. But yeah, they was definitely not engineered to be serviced. Honestly, like most radios. They were never really, most CB radios, honestly, they never planned on these things lasting for as long as they did. They figure radio breaks, you might get it fixed, but it's, by the time it gets old enough to where you need stuff like the electrolytic capacitors changed, they figure the average person's going to throw it away. So, yeah, serviceability's never really in the design when it comes to designing stuff like this. But, yeah, so it's back up and running now. It's a good working radio. Like I say, I just thought I'd quickly show this. I'm not sure if I've ever shown a 550 before. I know I've shown a video on the 555. Like I say, you can go look at that video. I may have even done more than one video on those. But the base station, you can go look at any of those, and you can see, yes, the inside's exactly the same. Actually, one of those that I did, somebody that had done a channel modification in that other radio cut the whole top of the can out, and I ended up having to patch the hole in there. That's how they got in it to do a channel modification. They didn't do the correct thing and actually remove the shield to get down inside there. But there you go. So there's a working Motorola CM550 ready to be put back into service. Not bad looking, like I say. The covers, yeah, he repainted them. They're okay. I'm not sure what the heck happened to the lens here. See that white line there and that white line there? Well, I'm never going to get that cleaned off. I don't know if the customer did it or if somebody else did it at some point in time, but it looks like somebody buffed this, and like with a high-speed rotary buffing wheel, maybe a Dremel tool with a little buff head on it, and they hit the plastic lens. and they let it sit there too long, and it actually melted into the lens. Yeah, that is actually a deep gouge. Those two spots are actually gouges in that kind of a purpley violet lens. But yeah, so there's no getting them out of there. You'd actually need to replace that lens. But it's perfectly fine when it's on. Actually, when the radio's turned on, just turn it back on here. Get her plugged back in, at least to power. You can see, yeah, it's not like it affects, because the digits are kind of small on these, so those two little spots are not even in the actual, viewing area where the actual numbers are. So there you go. There's just a quick video on a Motorola CM550.